Hello, Alexa developers. Welcome to the My Cactus Design and Build Customer Obsessed Alexa Skills Series. We are on episode. What episode is this,
Uh,
Justin? Allison?
Episode 9, I believe. Yeah.
9.
We're on episode 9, and we're going to talk about some really interesting things today. So I'm Joe Moyo. I'm a solutions architect with Amazon Alexa, and I'm joined by Justin
Hey, hey, hey. This is Justin. I'm an evangelist at Amazon. Teach people how to build Alexa skills.
and Allison.
Hi, I'm Allison Atwell. I also work at Amazon Alexa, and I help our partners, our third parties, design amazing skills, which is what we've been doing for the past 9 episodes now.
So let's continue our design to building. But first, a bit of housekeeping. So last week we talked about, last week we talked about the GUI design for APL. In this episode, we're going to talk about what we have added to that with the Web API for games and how we've built some of this. And as always, you can follow along with all of our resources, design and code, in the repo at alexa.design/my-cactus. So, with that, this is, stream number 9 in the series. Here is the calendar for all the past episodes, which actually, Justin, would you be able to post in a link to all the past episodes?
Yes, we actually have a link here on a collection here on Twitch, and then there's also a YouTube link. I'll have to pull that up, so give me a moment, but I'll definitely paste it in the chat.
Yeah, so let's continue on with multimodal experiences with the Web API. So I'm going to pass it over to Allison to recap our last episode.
Yeah. So last episode, we went over some best practices that apply to GUI, that is graphical user interface. If you are new here or haven't heard that awkward term before, right? But so we went over some best practices that apply whether you're using APL or Web API, and frankly, whether you're designing a chair or an app or an Alexa skill. These are pretty basic design principles for the most part, that just apply in general. So again, to recap, in previous episodes, we talked about using storyboards to do our voice design, which is what you're looking at here. And we're going to continue using our storyboards when we do our GUI. And so first of all, we're going to go back and we actually have in our Git repo there that Joe shared at the beginning of the episode, you will have all of these blank storyboards with no GUI on them. There's like one empty pot on one of the storyboards that you can see where I left space to do all of this work, and you can follow along and create your own simulator. So the next thing we did was talk about the essentials that we needed to include in our GUI. And if you follow these steps, the idea is that it makes a lot of decisions for you. So designing GUI, it doesn't become such a daunting task. There aren't as many decisions to make. It makes things a lot easier. If you follow all these principles, you'll end up with something, that's at least clean and customers find very usable. And hopefully a bit delightful. We'll talk about that. So of course, go ahead, Joe.
Oh yeah, I was just gonna say, we've written a lot about this in this blog here. So Allison and I collaborated on this. So if you want to, a lot more words to talk about some of these concepts.
A lot more
and a few
best
others.
practices in there, but also chatting about Web API, which is relevant to today's discussion. But yeah, a lot of same best practices that are in there. You would also see in the last episode, with maybe some fun additions, since we were a little pressed for time, which that's typical when you're making a skill. But we were pressed for time last episode, so go check out those best practices as well on the blog. So also we want to pick out the moments that are just essential. Number one, I'm going to expect to see my cactus. Duh. I'm going to expect to be able to use touch gestures to do similar things that I can do with my voice, such as if I say open the blinds and close the blinds, I can tap the blinds and the same thing will happen. Water the cactus, I can tap the watering can, and it's as if I said water the cactus. Of course, it helps to have the name of your cactus. That's important. It's not anonymous. We give it a name, we give it a personality.
Yeah, we
There
give
are
it a
three
voice too.
cacti. What's that?
I said we give it a voice too.
Exactly. It would have one of two voices, and then if you were using an APL version, had we created one, you would get one of three different cacti. So I'm a designer, I'm pretty bad at math, but there are a lot of different combinations, plus all of the different names to choose from. So it gives you a bit of variety. So you shouldn't get, the exact same cactus twice should you unfortunately kill one. So we want to, which segues into, aside from the essentials, which you can see here that I've chosen the essentials are our basic life functions here on the left. Of course, we need to see our cactus, and then we want to see its name and some indicator of its health status. That's really the core functionality of the skill. That's what I expect. Step number 2, complete. Next, we want to create something delightful. So in the last episode, I shared some of those things with you, such as getting a flower. We prioritize doing things like that because, after all, this is an experiment, sort of, also on our part, where we want to see how many people we can get coming back to the skill just to raise this cactus. And there's not a lot involved in raising a cactus. Why I'm able to have so many of them. They're not very high maintenance. So what else will keep you coming back to the skill and having fun and remembering to water your cactus if it's not always in front of you? So we talked about, let's pick some delighter things. So now I have some priorities on what I want to really put effort into the GUI for. Right. I don't need to show anything else on screen, really. I made some other supporting screens, such as a help screen, but those are all, I'd call them plumbing. They're not super essential to just core experience. So
right, and one thing that I want to go back to the impact and delight piece. We had talked about possibly using like the reminders API at one point to have the skill remind the user, hey, check on your cactus. And the way how the API works is the user has to basically request to be reminded, but we could put something in the skill that would let them know, hey, you can set a reminder to water your cactus or something, and then the skill will send a reminder when it's time to do it. So we ultimately didn't put that into the skill, but it's one of those things where it's like, hey, this is kind of a surprise and delight moment, and it would also draw people back to the skill to come back and oh, that's right, I gotta go water my cactus, I gotta go open the blinds. So
right, if there's a way to remind them to use the skill that's relevant and useful to how they play the game, definitely I would put that high on the priority list. And then also, if it reminded you of things like, if the cacti, like the cactus has news for you, and it's when it grows an arm or something, so you could get like really cool like life announcements, so you don't really miss those things. Because remind me, actually, what happens if I don't come back? Is there a situation where if I don't come back for a while, but the cactus is still alive, I would need to hear multiple kinds of reward messages? So like, the cactus grew, it had a birthday, you got a badge. How might that work?
Yeah, that's a good question. We certainly could build it.
How edge is that edge case?
Yeah,
it depends on when we implement the increased water capacity, I think,
yeah,
because that's kind of the
Right.
limiting factor right now.
And we also,
Yeah.
in the beginning, we had implemented the latest status message. If you remember, like that's in the last episode I pointed out, like, or 2 episodes ago, I pointed out that's how we, keep track of what the latest badge that they unlocked was. And when I first implemented that, I implemented that as an array, and so every time they unlocked a badge, we would just push something into that, and then what would happen over time is you would get this really long list of the things that they unlocked, but it was a first in last out kind of thing, so you could just loop through it and figure out like, but in order to like not repeat the same messages over again, you'd have to have somehow to either clear those items, or maybe set maybe instead of having it be a string, be an object, and when you announce those things, you clear them with like a flag, true false. And so once it's been,
Yeah.
so that's something that we could do, but again, yeah, like, and it's the way it's
Or we
currently
could
implemented
just
doesn't.
design the mechanics so that that case never comes up.
That's
And
true.
that's kind of
And
how it
then
Yeah.
we
works,
don't
right?
have to do that. Yeah. That might be how it works today. It might not be possible for that to happen if you don't come back for long enough. You're just going to get the death
Yes,
message
that's exactly what
instead
happens.
of.
Yep.
You just get the death
That.
message.
Okay. Yeah.
because
Okay.
if because we had talked about like doing an ISP where you have like an auto water function, so it would like automatically water and take
Yes.
care of your cactus. And so if we were to do something
Sprinkler
like, yeah,
system.
if we were to do something like that, then yes, we would want to have, we would want, it would be necessary at that point to have that queue of, here's all the things that happened while you were away, because the skill will be, the will be basically managing it itself. So in that case, you would need to communicate like, hey, this is what happened while you were gone.
Yeah. Okay. This all makes sense. I hadn't thought about that extreme edge case before. For good reason. I assumed it wouldn't happen. Um, okay, so we've got our storyboards in front of us. Most of them are blank at this stage, or they were blank at this stage. Not quite. So we know exactly what our high value screens are going to be. We know what our priorities are as far as the content that goes on them. Well, now how do I like put them on the screen, and at what time do I do that? Where do I go now? So deciding what to put on screen is pretty important, because that also might affect how you read out your script. Often you can get away with saying a lot less in your script if you've got something on screen for the person to look at. So if I were looking at this screen, I might be able to say like, your cactus is healthy. And that's probably sufficient. I don't have to like read the health or anything like that. But in the headless version, where there's no screen to look at, I might need to say a little bit more. So you're
Mhm.
also going to document that on your storyboards. That's where your paths are going to kind of split ways there. I don't do that. I try not to do that super often, but sometimes it's the right thing to do, especially if you're dealing with a lot of information. So that's what I mean when we say we want to start voice first, which is I want to primarily interact with my voice. I want to hear the core content, what's going on. This is an audio experience. It's heard first, and then you interact with your voice. So I want to make sure, of course, that I can say open the blinds and water the cactus, and I don't require
Mhm.
somebody to tap the screen. So that's what I'm talking about with step number 4. So now we know we can go about deciding what information to put on screen when. So step 4, now we can actually, sometimes I just write these things down when I'm writing storyboards. When I'm over here writing the script on the right, I am actually making notes on the left, just a list of the things that I want to put on the screen. And that eventually becomes a wireframe of the shapes I'm going to put on the screen, the general shapes, and then I put colors and character and actual design on top of it. But I'm going to prioritize information that's really glanceable, such as general health. I can look at the screen background, the wallpaper changes color based on the cactus's health, and then of course there is a literal health meter with a color and a percentage, so nobody is mistaken as to whether this cactus is healthy or not. It's actually neutral right now, so it gets neutral color. 70% isn't bad. It's an okay score for health. So that's me prioritizing my contextually relevant glanceable information. Now, context is important. Every screen that you use, you might not need to design a separate screen for every single turn in every single conversation. That's not what we've done here in the skill. Joe will flash the storyboards here in a minute. Yep, awesome. So that's you notice a lot of consistent screens. Actually, well, mostly these are varieties on different states of the cactus, but you don't need to use a different design for every screen. In fact, you shouldn't do that. Like screens should look like each other. So we're not going to like move the cactus around the screen at any time, or we might animate it at some point, but that's different. We're not going to like suddenly change where we put the health meter or something like that. So once you have a consistent layout, you actually don't need to do that many different layouts. As you could see there's only like 3 or 4 in the scale, and only one is critical. Honestly, the one layout, that's we could have gotten away with just this one layout, and I would have been happy. I'd be happy launching that even.
I do like the badges though, which is
of course.
we'll
That's
see in
why
a
we
second.
prioritize them. Because they're delightful. They're part of our retention strategy. If we're gonna put the badges in there, you want to like make sure people know that they're there and that they appreciate them in any way possible.
Right.
For us, that was making a nice screen, and that was writing a poem every time you got a badge. So
Exactly.
you're welcome for my poetry. Thank you for playing.
And those badges is part of that retention mechanism to get people to keep coming back to the skill, because
Right.
if they see that, oh hey, I get rewarded for playing not just once but for multiple times and for doing various interesting feats in the game, it's gonna incentivize people to keep playing.
Right. There's all kinds of reasons that they would keep doing that, because we're human beings and we're curious. Is mostly how you could bucket all of those reasons. And maybe you like poetry, or you just want to see what wacky poem Alexa's going to read next. This is my theory, that if you celebrate a badge in some way, instead of just giving it to somebody, and just telling them they earned it, that's a bit more valuable. That's my theory, at least. We'll see what happens after we launch this. I've made a couple other skills that use poetry as well that I'm monitoring. I'm a veteran poet here, Alexa poet.
It reminds me of our Alexa Live 2019 talk, where you and me were sitting together and somebody took we were both wearing black. I had that coat on. And
you're right.
Like somebody, I don't remember who it was, but tweeted at took a screenshot, tweeted at us, and said it looks like Justin and Allison are getting together to read poetry.
Right, it looks like a couple of beatniks. We were just missing the drums.
And here we are talking about your poetry.
Someone get me a drum for our launch party, and I will play it. I will do a live dramatic poetry reading. I'll dig out my turtleneck and everything.
Nice.
So anyway, we know what information we want to prioritize. Now we just need to put it on the screen and figure out how we're going to present it. So at this point, you've probably sketched out what you're putting where. Maybe you sketched a couple of cacti or whatever it is that you're simulating. Maybe it's a plant, maybe it's a fish or something. So we're going to create a grid, which just means we're going to divide the screen into equal sections, and then everything that we put onto that grid, whether it's a text box or a headline or the cactus, this is a 3-column grid, so the cactus pot is actually exactly 1/3 the width of this screen, and it's roughly a 3-column grid vertically and horizontally. Yes, thank you, Joe.
I'll draw some very
excellent illustration. I love it. That is a snazzy grid. That's gonna look great. So every element I put on there is going to quote unquote snap to this grid. So that means all of our elements are going to be in equal proportion to each other. So that's going to make it look very clean. It's going to give us a natural hierarchy. Most important elements will be bigger than others. And then create the hierarchy. I actually work in black and white until I've got a nice grid and a nice wireframe going. And then I go in and choose my colors. Choose colors with meaning first. So, of course, the cactus color, yeah, it's going to be green. I'll decide what color green later. But what I wanted to do is like pick out the wallpaper colors because that was going to be like the most important thing you're going to see. It's the indicator of the cactus's health. Of course, the other smaller colors were less important, but I picked out those colors first, and then I picked out a nice contrasting green. Um, but then any type you're going to put on screen, you're going to create a hierarchy. Of course, you can see basically on Prickly Pete is a lot bigger than, day two, health, water, um, all of that. And then we shared with you a few tips, but also check out on the developer portal the Amazon Alexa design page, the design guidelines.
Yes.
You're going to want to check out more accessibility guidelines. Those are a lot clearer. I shared the most important ones last episode, but basically color contrast is very important. So you'll notice on this screen, my green and my neutral background color aren't actually contrasting that much. They contrast better with the other backgrounds, but I put a white line around it. So now I have very high contrast colors between each other. So now anybody with any kind of vision impairment, myself included, now you can actually see a bit better all of your graphics and stuff. But it's very important when it comes to type and using color against color. That's kind of the number one mistake I see in the way people design their GUI. That's like the first thing I notice. It's like, oh, that's white type on a light blue screen, huh? You want a high contrast, and you can calculate. Just do color contrast calculator in your search engine of choice, and you'll find tons of helpful tools to help you get the right target. Which those targets are also on the developer portal. So that's what we covered last episode, as far as best practices go. And I will kick in a bit more as we talk about Web API, but Joe is now going to take it away. Actually, we can review again. We talked about I forgot about these actually. We talked about our vision patterns, natural human vision patterns, and helpful ways to lay out your screen. These are two ways that we tend to read screens and also print material to some degree, especially our zigzag here. So if you arrange your hierarchy when you're making these decisions on where to put things, arrange it so that they follow one of these patterns, that will also help you out a lot.
And so what we ended up doing actually, so you can see the APL design, which was in the storyboards, and then you can take a look here as to what we ended up making for the web API design. And it follows a similar kind of pattern, right? The that core of the game is immediately what your eye is drawn to. Um, and then you can see that contextual glanceable information. Maybe I actually should have had one covering the whole screen because that this background is dynamic as well, and will change based on the health. And then you can see the badges, which is kind of less important to to a quick glance. That's kind of off there, off in the left there.
Yeah, we also talked about last episode. The way I arranged my screen was any life functions I put to the left. So the actions are water and blinds. So I put those off to the left. Those are kind of grouped, to one side. My brain knows that that's where that stuff is. And then on the other side is all has to do with stats. So if you were to tap on our little reward or our little trophy there, or
Hmm.
our picture frame, you would get to your cactus stats and your badges, and then below that, of course, is our health meter. So you actually did something different, which is fine. I'm working with a flat space, so I don't actually have that much space to work with. You actually have a lot more space to work with. Do you want to talk about that, like how you can kind of pan around and everything?
Yeah, so actually, I think we're gonna see a video in a second, and there's a little bit of
Awesome.
panning in there, but this is a 3D scene. You can move around with touch. It's one of the extra delight points that we were able to add because we were using the web API and could have a 3D scene. And you could see a little bit in this screenshot as well that there is some dynamic lighting here. So there's a spotlight that's showing mainly on the left side here, and that will change based on time of day as well, and it's more visible when you pan. Um, yeah, the other thing to note here is, like, we probably could use this space a bit better. Um, the main thing is like, being in a 3D scene, we need to adjust some of these 3D models,
Right.
I think some, to kind of fall a bit more in line with the main storyboard design.
Right. And
So
actually, since we have so much real estate here, I would make a suggestion that we should have a trophy and badge shelf where one sees all of your badges and
Yeah.
you could like tap to see more. And whereas in the APL, we need to go to a different screen to do that. Here we could just make that part of the room actually and
yeah.
have the shelf there.
Yeah.
That would be that would simplify things greatly if you had everything there in front of you, but it also wasn't cluttering up the screen. It was, maybe peeking off to the side as your default view and you can pan around and see more. That would be
Yeah, and the fun
lovely.
thing about that is you can
Yeah,
see like that collection grow over time. And so like, you know, I
Right.
don't know like whenever I play a game and like there's something that like I collect and you can watch that collection grow over time. There's something really
Right.
satisfying about that.
so actually, on this note, let's take a little look at a video of the experience, Justin.
Prickly Pete is feeling neutral right now. You can open the blinds. You can open or close the blinds, water the cactus, check its status, or check your badges. What would you like to do?
Water the cactus.
Ah, that hit the spot.
You can open the blinds.
Open the blinds.
Ah, sweet warmth. Thank you. Prickly Pete is feeling swell.
Today I did yoga in the window for 16 hours. I'm best at cactus pose. I don't need anything right now, thank you.
Check my badges.
You haven't unlocked any badges yet. Keep playing and I'm sure you'll unlock something. What would you like to do?
All right. So that was the video.
First of all, it's dancing, and that's a huge improvement.
yeah, having a 3D space with animations is, definitely gives you more opportunity to show delight, right? You could see a few things in there, some nice Easter eggs, the animations. One thing that wasn't captured very well is mainly because it's bugged and not working currently, but there was some background audio that kind of loops
Right.
and keeps you kind of in that space, which allows us to kind of use the longer session. But this actually brings up a question here that I have, Allison. It's like APL or Web API for games. I'm making a game. Which one should I use? And I
Right.
don't think there's a right or a wrong answer here, really. But
Oh, are there wrong answers? I mean,
well,
The
there can
wrong
be wrong
answer would
answers.
be the one that you costs you extra work but doesn't give you your skill specifically maybe the benefit. So that could be either APL or web API for games depending on your situation. So that's why
Yeah,
we're going to have this discussion.
if you're not adding anything to the customer experience, or if you're taking away from the customer experience, you certainly don't want to, well, add that to your skill. And like an example of that would
Definitely.
be using the web API for something that is just purely complementary in a visual, because it takes some time to start up the web API, whereas APL is immediately rendered, more or less. But that said, like, what about all those times like this skill where the voice response is fairly long? You're getting a nice poem when you join the skill. You're
Right.
hearing some sound effects and seeing some animations play with that. And we could have APL animations.
Yep.
Um,
Right.
so why choose one or the other in this case?
Oh, so, well, I mean, first of all, as we've told our audience before we started APL, you showed up needing a web API project, but that is not necessarily like the primary reason I would choose
Ye-
it. But full disclosure, we needed
that
help and you needed skill.
Right. And
that is true.
But
and
That
our
is
original intent was to reach out to you to help us with the APL portion anyway. And so when you're like,
you would have been too busy working on the web API skill, so.
That said,
Oh.
I feel like I was able to convince you all by saying how we can make a 3D scene and we could
Right,
have
right.
dynamic
That was
lighting.
gonna be
right.
my first choice actually was as a designer, the 3D. Not only is that just a capability that we personally wanted to show off as the ability to handle the 3D modeling is or the 3D graphics is we thought that would just be more compelling and actually what we just talked about with like including the shelf in the scene having that extra real estate and this being a character game and being in one scene it's totally great. I can actually remove UI from the screen and make it easier for the user to use because the badges are right there in the same room as the cacti and it makes a lot more sense. You don't have to discover or ask for your badges; they're just right there. So that's that's a that's a reason I would do that for a customer as well as that access to the badges, having more screen real estate in this lovely scene that's very 3D and immersive, and the story makes more sense this way,
Yeah,
honestly.
and oh, sorry.
Yeah, so
I was just gonna say that like I think the one of the things that Allison and I had talked about before Joe joined the project was like how can we do some really cool dynamic things with APL, like show an animation of blinds opening and closing. How can we indicate that it's nighttime versus daytime? And so when part of that discussion that we had with Joe was like, hey, we can do these things easily with the web API for games.
Right. You just hit a few huge functions that Web API actually did a bit better, which is opening and closing the blinds. Like animations in general, they're a little bit easier to work with and do in in code over but I've actually seen some really simple, elegant animations done with APL that people have actually shared openly. You can
yeah,
find a lot of those on GitHub. They're great. But if you're looking for a little bit more, maybe you need the timing to be just right. Um, that's when you might choose Web API for games as well. And with this, we can actually drag the blinds. We have very fine control over the blinds if we so choose to exercise it. So that was one
yeah,
thing, Justin, you just hit on. Go ahead, Joe.
yeah, definitely. And then another thing we've talked about as a group is having some ambient gameplay, and we weren't able to prioritize that for right now. Well, only minimally have we kind of built something around that. So using the web API for games lets us have like a little touch mini game or something you could play with a Fire TV remote. Um, like swat the flies from your cactus or
Right.
protect it from the spider.
Yeah, you saw in there that spider. So here's another thing we can do. We can keep the session open. So if we keep that session open and it's just a cactus scene, and also, oh, by the way, there's, dynamic lighting in Web API, I don't have to generate all those images for different times of the day. As we go throughout the day, the spider can come in, and you get rewarded for having the skill open and quote unquote staying in the skill by smushing the spider. When it shows up, you get some kind of health bonus or something. So double whammy there, the lighting and the open gameplay, which are both ambient gameplay, really.
Yeah, so like I guess to sum it up is like the main reason we chose this is just the ability to add extra delight was worth it.
Right. And that was our whole goal with the project, was retention, and we thought this had really brilliant retention opportunities that Web APL didn't have, or didn't have as much of necessarily. So that's a big reason we went with it, to experiment with retaining people. If you have a cactus on your screen all day and spiders show up, are you going to swat them away? How long will you do that? We'll find out.
So let's continue building and look at some of the things that we've done with this, and how we've translated some of these design things we're talking about into code.
All right.
So just a refresher here, we have our architecture, and the bulk of the skill data, the skill interactions, is still living in the Lambda. Even in this, we're what I'm calling skill side authoritative in our skill. So the is voice, and the Lambda drives all of the state changes that are core to the game. Then we have our S3 asset storage, where we're uploading things like the HTML for the page, the image assets like the badges, the background, etc. And this is being served from a CloudFront content delivery network to be close to the Alexa device and our nice little customer. And just a recap of what we've kind of identified as those core components of the game. So these are all the different functionality that we've implemented on the back end. So those life essentials, the rewards, and some miscellaneous things. However, we've added some more with the Web API. So things like touch interactions were added. We've added additional functionality to things like the growth and aging and the badges with the visuals. We've added some new Easter eggs in. This is just something that doesn't exist in the voice version, like the cactus dancing or the spider crawling around. And so the 3D animations also fit into that bucket. And then on the miscellaneous side, we've added additional sound effects with a repeating web audio loop. We've added dynamic lighting. We've added the longer session with the ability to have those that ambient gameplay. And we can now even track some metrics on the front end with some front end logging. So diving into each of these, let's talk about what you do first when working with Web API. And that's initializing the Alexa object to be able to communicate with your backend. And here we have our code. So initializing Alexa actually starts with the HTML itself. So let's look here.
Yes.
We got to pull in our. Oh,
Let's also zoom in a little bit so people can see.
Oh. Yeah, good call. All right. So first up, we're pulling in our JavaScript asset, which is going to be loaded on the web view on the device. This isn't going to work in your browser for local testing, and we'll talk about how we worked kind of around that a bit. Now, this will allow us to then reference that Alexa object, which we do in our main index file. So all of our JavaScript files actually, since this is running in a web browser, I like having modules. I like that code reuse and separation. So we're using Webpack in order to pack that all up into one main JavaScript bundle to be uploaded to the S3 asset server. Now, when we're this setup Alexa is called as a part of the initialization of this JavaScript page here, and we get both a success and a failure callback. So once we create it in our success callback, we're storing a reference to the Alexa client, and then we're setting up some of our core modules like the message sender, which is used for logging. We're logging some information about the device specs to the backend. And then we're actually setting up our game state. So this initialization comes with a payload that we've seen a few times throughout this series. It's the same payload that we're working with on the back end to make all of our state decisions. We're synchronizing on that in the front end here as well. So our refresh game state is going to be called every time we get a message payload, including on start. We'll start our background music. And then we register our different handlers for different events that are provided to us with the Web API for games. So here we have just something really simple for on speech started and on speech stopped, which are called when the text to speech is playing. And we reduce the volume of the audio, and then we restore it back to where it was when the speech stops. You can do some more interesting things here as well.
So what I have a quick question. Why is it that you're manipulating the volume level during the speech?
Yeah, so to be clear, this is manipulating the volume level of the web audio. So this is what's being played by the browser itself.
Okay.
The text to speech is coming from our backend, and since we are skill side authoritative, we're keeping that exactly as is. And you see it lines up actually pretty nicely with the animations. The speech for the water sound, for instance, plays as the water pail goes and animates. This can give you much finer control if you'd like. And there is even a function to get you even more control with fetch and demux MP3, which would allow you to play the text to speech as web audio, and you would get the phoneme data. So the different like mouth movements that would be made when you're pronouncing those words, you could then use in your code. Very, very cool.
Yeah.
We don't have a face to animate here, so we're not doing any of that. But that's a nice way to keep consistent the audio on your headless experience and your multimodal experience while still having tons of control.
That's cool. And
But yeah,
something that I didn't quite realize about this experience is that like, yeah, you have, it's skill side authoritative where like the interaction and everything that's keeping track of the simulation is being taking place in the skills backend. But I didn't know that you would also have your own audio that you would play from the web API side of things, which is pretty cool. Like I'm excited. I'm learning about this as we go along, and so I'm gonna probably interrupt you several times and ask you some questions about like, oh hey, why is this different? Because this is like my first time outside of like going through some of the code reviews, learning, and so I think the questions I'll ask will probably also align with some of the questions that our audience has as well. And in the chat, if you have questions, please drop them in, and we'll try to answer and address them.
Yeah, absolutely. Now we've got this on message callback too, and this does a lot of heavy lifting. Let's come back to it actually, because this is something we'll talk about for some of the other web API specific things. And last up, we have something very similar to those speech event callbacks. We have the voice on microphone open and voice on microphone close, which are called when, well, the microphone opens or closes. You don't want to be playing audio over your customer who's trying to speak to the skill. So that's really the problem we're solving here. We're doing the same thing, ducking the audio and then restoring it again. But of course, you could do much more with this. Now, that's our success callback. When we look at our failure callback, this is going to be called anytime you're developing in a web browser that's not on the Alexa device. So your Alexa JavaScript module isn't going to load, the alexa.create is going to fail, and you're going to get into this catch block. And what we're doing here is we're actually simulating different states. So we're mocking out the moment time object, and we're mocking out the entire data payload. So we're involving this mock data, and what I can actually do is actually switch between different forms of mock data, right? So this has things like the badges you've unlocked, times you've checked, so everything that's in our session attributes. And in code, this lets me then easily test like a state where we have no cactus. Here's a state where we do have a cactus, and here's the state of it. So I can actually do the development on the GUI without needing to work with the skill side for getting those things like animations, touch events, etc., all correct. So that's kind of the core of the initialization logic there, both when we're on device and when we're not. And it's also worth noting we're using Three.js as our rendering engine, as well as our web audio wrapper. So all of this is through Three.js, and that's loaded in as well in the index HTML. And we initialize our actual objects using 3D models through Three.js's loaders. Now, if we go back here, let's talk about the next part, the reactive GUI. And now I'm going to talk about that on message, because the on message is our mechanism to actually react on the graphics side to what's coming from our backend. So let's actually start here with our backend code. So I'm going to go into index, and let's take a look at like water cactus intent. So the communication is bidirectional with Web API. And we mentioned briefly before, Alexa actually sends a different kind of request, the message request, when you have a request coming from the JavaScript side. I decided to stick with the same kind of intent sort of paradigm, and I actually send some data that says the intent type that I'm triggering when you have that touch interaction. So regardless of what's happening here, what we're doing too is when we do support HTML, we're sending an additional payload. So this is using the handle message HTML directive. And here we're sending an intent. So in this case, it's water, and whether or not we want to play the animation, and then the game state. So that profile information we've been kind of building the rest of our logic off of. So when this gets to the front end, it's going to be um, executing our on message callback. Here, we make sure that we have a game state object, and if so, we refresh the game state. If we don't have a game state object, that's an error. We need to fix it. It's a bug. We're going to log an error. Then we check for badges. If there's been a new badge, if there is, we'll use our window manager to show the new badge, and then it transitions over into the full badge list that we saw before.
And is that
last up,
for like if they've unlocked a badge, or is that like net new badges? Like when is that triggered?
Yeah, so this is going to happen when there is a block of unlocked badges at all. I'm actually not totally sure why I put this logic in. Probably I hit a null pointer at some point. And then making sure that there is a new badge flag being sent. So this was something I added to that profile. When there is a new badge unlocked, we set a Boolean that there is a new badge, basically.
I see.
And the customer is going to get a message about what was the latest badge that was unlocked and things like that as that screen shows. And then finally, we're going to actually play our animations. So since the animations are played locally, we have to trigger them locally. And we do this, we actually encapsulate the logic to control each type of object in a class. So here we have pale class, blinds class, window manager class, and the cactus class. Which actually brings us very nicely to our next topic of encapsulating the view logic. So let's look at one of these classes. So with the cactus, this is one of our more complex ones. And we have an update function, We have an initialization function, which actually just sets the data payload. This is called every time we refresh the visuals. It's going to reset the happy days. The happy days is what we're driving all of our visual logic off of. And then we have some logic here that's used for the click handlers, which I won't go into, and then actually loading the scene and playing the animation. So, looking at the update. So this is where the bulk of information happens. Update is called every frame of our game loop. And we pass in the change in time as this variable delta. So it's the change in time from the last frame. This allows us to then play our animation so it's consistent regardless of exactly the times that the rendered by the rendering engine. And the first thing we call is set object and scale position. So we're going to scale the cactus object according to how old it is. This allows it to grow over time. And then we have some logic determining when we should show different arms, depending on how old the cactus is, and even when we should show the flower or no cactus at all. So this is the core of our render logic called every frame, and really kind of drives that the growth of the cactus. And each of these other objects has something similar. Usually the update functions are quite simple, like this one, the pale. It's whether or not we are running the animation, basically. But if we wanted to extend it with more things, like play some web audio as a part of the pale animation, we could do so here. So it gives us a lot of control over the visual presentation of those reward objects. Next up, let's talk very briefly about front-end logging and metrics. And I think I saw a question here about how to debug the web API side. So debugging has a couple of parts, some of which we've covered, right? So first up, to debug, start in your local browser, use mock objects to simulate what it would be like if it's running on an Alexa skill, and then you have access to all the browser tools locally. You can resize the screen to make sure your visuals react accordingly, et cetera, et cetera. So that's a great way to start debugging. The next level of debugging you saw in the video, where we're just logging to the screen. And I can actually show some of the code that's doing that here. So we have a debug element. It's a DOM element that's at the top of the screen. And we just append text to it, just like you would append in a console log. And this works pretty well. You don't have access to all the nice debugging tools your browser gives you, but you do get to see across devices what's going on. And you notice here where I'm showing this, we are also calling this message sender.log. And this is actually going to send the message to our backend. However, there's a bit of a catch. So this code is it's actually doing a batch send. And if I go into the message sender, if I can find it, what did I do with it? Here it is. All right, so message sender. What we're doing here is we're holding a reference to the Alexa client because we're going to need to use the message send API. So that's Alexa client.skill.send message. This allows us to put an arbitrary payload in. Our payload here, in this case, is going to be the intent to log with a message queue. This queue is built up over time and flushed every half of a second. So we're configuring it that this, 500 milliseconds. So every 500 milliseconds, we're going to flush the message queue. This allows us to avoid being rate limited. If you send a log every time you want to log, you will very quickly spin up new lambdas and probably even be rate limited by the JavaScript client itself. You can only send, I think, 2 messages per second per the documentation. So certainly, if you're going to use this approach to debug, this will allow you to then log in the backend your CloudWatch logs. So this is a pretty powerful way to do it. And it also allows you to get metrics at scale. You can use a mechanism like this or very similar to track user behaviors that are happening on the front end that don't have a back end component associated. For instance, like squishing the spider. If we want to see how many spiders have been squished across all players in the game, we could start tracking that information through a mechanism like this one. So very powerful for understanding how customers play your game. And we're handling different cases. Like we do get this status code of 429 when we're being rate limited. We get a 500 if there's a server problem. And this code is actually comes out of from me hitting Lambda concurrency problems and spinning up to 3 Lambdas at a time for one customer on the skill. So that's not an ideal scenario. Makes it very challenging to debug when it's split all over the place. So there is some other cool code, but I don't think we have time to get to it today. But let's shift gears back to our overall time frame here. And if you have more questions about Web API, how we did this, check out the code and feel free to reach out to me. Happy to chat anytime.
Yes, and somebody was asking about how do they, actually. I think the question was how do they invoke the skill, and I think it said how do we invoke this, and I think that means how do they actually like launch the Web API part of the skill, and I don't think we covered that part, but I know we're out of time, so maybe on the next episode we can go through the code that launches it.
It's a simple directive, the HTML start directive, and you point it to a publicly accessible HTTPS link. Has to be a valid SSL cert as recognized by the device. So we're going to actually talk more about that in depth next episode on our development process deep dive, because there are some there's definitely special things that we did to develop with the Web API side, as well as our backend. So I think that'll be an exciting episode. Hey, Justin?
I think so. Awesome.
Yeah, we're going to talk about how I handed off that huge stack of storyboards that Joe showed in the beginning, and it became what you're looking at today. Which we've done to some extent, but there is a process, and that's what we're going to cover specifically, plus all of the code that came about from that process.
Yeah, definitely. And we've got a few more episodes remaining. As always, follow along at alexa.design/My Cactus for the design assets and the code assets. And here's our cactus pun of the day. Hey? Up next, learn how the 3 arms of our team grew a cactus skill together.
We are the 3 arms. Instead of the 3 musketeers, the 3 arms.
The 3 arms. Funnily enough, there are 3 growth states of each of our 3 cacti. So there's the sprout, and there's the one arm, and there's the other arm. It's perfect. Oh, next episode, I know there's always a lot of questions about certification. So I interpreted the earlier question as how do you actually ask my device for the skill, as in how do you launch the skill. You can't launch the skill on your device today. We haven't submitted certification yet, but in the end of all of this, we will invite you to the beta program, and eventually we'll get there. But we are next episode going to talk about some tips to get through certification. We've all been there before, so even though our skill is not currently facing those that friction or that struggle of certification so many of us are familiar with, we can share a lot of our tips. So stay tuned for that on Friday, same time, same place.
All right.
And until next time, we'll see you all later. Thanks for hanging out with us.
All right. Thanks for tuning in.
Bye.